Hey guys, welcome to our video on radical functions. So, a radical function is really easy, kind of easy, something we've dealt with, and a radical function is simply something that deals with a radical expression. So what is that, right? Let's start with there. This right here is a radical expression. You say that n is the index, that is the radical, and in this case x is what we call the radicand. Okay, the radicand is just whatever is underneath that radical symbol. Okay, so quick little terminology out of the way. Really simply, a radical function is any function that can be written as So, a radical function is any function that can be written as f(x) equals the nth root of x, where n is a whole number. So, 1, 2, 3, 4, 5. We don't really talk about the 0th root, that doesn't kind of apply. So, whole numbers. Now, that gives us two possible cases. We can either have n be even, or n is odd. Okay. Now, what these two things really affect is the domain, right? I mean, if n's even or odd, doesn't really matter. You can evaluate this the same way. So the square root of x is simply saying what number times itself equals x. The cube root of x would be what number times itself 3 times, so x times x, or a times a equals x, right? Now, what's really cool here is in this setting, okay, where the radicand is just x. If n is even, our domain is going to be 0 to infinity, including 0. You can take an even root of 0. I mean, just for imagine square root. The square root of 0 is 0, right? It's just saying what number times itself equals 0. So, we're not dealing with imaginary numbers here, so no negatives, okay? Now, if n is odd, so 1, 3, 5, any of those, our domain is everything. Okay? And so that's really the big takeaway here, right? If n is even, then our domain can only be positive numbers. In other words, the radicand has to be positive. Where if the domain is, or if n is odd, the domain can be anything. We can take the odd root of anything. Okay? Now I said root, right? That is one of the ways we refer to this. We'll kind of verbally say this is the nth root of x. Okay? So instead of the square root, the cube root, the fourth root, we'll say it's the nth root. So you could say the second root or the third root instead of the square root or cube root. So that is a radical function. There's not really a whole lot we're going to do with these more so than solving some equations, just getting some kind of algebraic practice with these. So, before we solve equations, I want to talk about a couple of properties of exponents. These are things that you should have covered in previous classes, but I want to refresh our minds on these just to help ourselves out. So if I have, let's see, if I have b to the m times b to the n, that is simply b to the m times n. If I have b to the m all to the n, that's b to the m, oh wait, sorry, this over here, plus. This is b to the m times n. Okay, so if I have the same base, so if I have something raised to a power times that same base raised to another power, we add those exponents. Let me make that a little clearer. Okay? But if we have a base raised to a power raised to another power, we multiply those exponents. Okay? Another one we're going to need is if I have b to a negative power, whatever that is, it's just 1 over b to the positive power. Okay? So if we have a negative exponent, we take that whole thing, the base and the exponent, and we put it in the denominator below 1, and then we just make that exponent positive. Okay? So that's what we do. We take the whole thing and move it down if we have a negative exponent. So those are some of the ones. Now, the one we really want to worry about for this class, okay, is, and I'm intentionally writing this in the middle, is what if I have b to the m over n? So if I have some number raised to this fraction exponent, this rational exponent, it can go one of two ways. Both ways are equivalent, they're the same, doesn't matter. So I can write this as the nth root of b to the m, but I can also write it as the nth root of b all to the m. So the difference here is just simply where that m is, and it doesn't matter where it is, whether it's inside or outside. What matters is it's applying to everything here. Okay? Let me give you an example of that. If I have something like the third root of 3x squared, okay, this is not this. And the reason why is because this second power is not being applied to everything here. It's only applying to the x. So if I wanted to, say, rewrite this in exponential notation, so I wanted to go from here to here, okay, the 3x squared, that's my b. So what this is equivalent to is this would be the same as 3x squared to the 1/3. Okay. From there we could expand that a little further. We could say it's 3 to the 1/3 times x to the 2/3, right? We get 2/3 because we'd have x squared to the 1/3, which would just be this. So we multiply 2 times 1/3, gives us 2/3. Okay, that's what that is. I'll move out of the way in just a second. But if I have something like, say, the cube root of 3x squared, now here, because that squared is now applying to everything, this is just this, and so we would end up with 3x to the 2/3. Okay, so there's a couple examples of practicing this. On the practice assignment that is down at the bottom of the My Open Math page in a separate folder, there's a few problems that practice kind of doing this. It's a good idea to go and do that. It's definitely going to be helpful. Okay, so there's that for you. Why do we care, right? What does that matter? Well, especially typing things out in a computer, it's a lot easier to type things out using an exponent as opposed to putting in roots. And so you may see functions defined like, say, 5x plus 15 to the 3/2. Okay, and I may say, what's the domain? Looking at this, I'm like, there's a lot going on here. I've got exponents, I've got linear function thing. I don't know. So if we change this from exponential form into a radical form, what we end up with is we get that f of x, okay, my root, the index of my root is the denominator here, right? So when we're looking at these rational exponents, the numerator is the power, the denominator is the root. So this is going to be the square root of 5x plus 15 cubed. Now, it doesn't matter if that cubed is inside or outside. I put it outside just because for domain, I'm only concerned with what's underneath the radical, and so I want to simplify that as much as possible, right? I don't want to try and figure out when 5x plus 15 cubed is in a range. I'd much rather deal with 5x plus 15. So, all I've done so far is I've converted from exponential notation to radical notation. I'm trying to figure out the domain. With radical functions, we had two cases. We had one where the index was even, and one where the index was odd. Our index here is even. So that means whatever the radicand is has to be greater than or equal to 0. So 5x plus 15 has to be greater than or equal to 0. So to figure out our domain, we just have to solve this inequality. That's it. Well, linear inequalities are really easy. So we're just going to subtract 15 from both sides. Get 5x greater than or equal to negative 15. Divide by 5. We only flip our inequality if we multiply or divide both sides by a negative number. Since we never did that, we're good. So we end up with x greater than or equal to negative 3. So what that tells me is my domain is all of the x values that are greater than or equal to negative 3. So my domain negative 3 to infinity. That's it. Pretty easy. Now, there's actually kind of a cool trick. So, got that. Make sure you write that down. I'm going to erase the work because I want to keep this. If I do this, I can rewrite this. And square root, you don't have to put the 2. If there is no index here, it's automatically assumed it's a 2. Okay? So, what I did there is I factored out that 5. So I pulled the 5 out of both the 5x and the 15. And I'm left with this. Why this helps is because this now looks like transformations. This plus 3 is a horizontal shift left 3 units. So it took our domain of the square root of x that was 0 to infinity, and it moved it 3 units over to negative 3 to infinity. So if you can see that as a transformation, sometimes finding these domains are really easy. Okay? Awesome. So we talked about finding a domain, we talked about changing from exponential to radical form, and you can go vice versa. Okay? Now let's solve some equations. So, what do I do? The first thing we want to do is we need to isolate the radical. We need to get that radical sign on one side of the equation. Once we've got that done, okay, which in this problem it's already done for us, once that radical is isolated, we square both sides of the equation. Now in this problem, there's really no issues. On the problems we're going to work in a minute, there's going to be some issues, and I know you guys are going to make this mistake, because everyone always makes this mistake, but you're not going to, because I'm telling you now to not make this mistake. So, don't do it. So, we're going to square both sides. Square, square. We have to square the entire side, right? We're not squaring each piece, we're squaring the whole thing. So when I square the square root goes away, they cancel each other out. So this left-hand side just becomes x minus 7, and 3 squared is 9. Cool. So now I just add 7 to both sides, and I get x equals 16. Awesome. Now we're not done, because it is extremely important. I cannot emphasize how important this is. With radical functions, you have to check your answers every single time. So go back to the original problem and check your answers. Okay? So, square root 16 minus 7. I put a question mark when I do checks. It's right. My what kind of way they're saying, does this equal 3? So we just go through. 16 minus 7 is 9. The square root of 9 is 3. 3 does equal 3. Check. Problem done. We now have our solution. Our solution is x equals 16. Okay? Not too bad. Not too bad. Let's try something else. Actually, yeah. So, okay. So we have the square root of 2x minus 2 equals x minus 1. Again, our square root is already isolated. Our radical is already isolated. So all I need to do is square both sides. Okay? Since this radical is over this whole side, just squaring like that, I can kind of not put the parentheses because everything's already grouped under that radical. But over here, I need to have parentheses. Because I don't want it to be like x minus 1 squared. Okay? And so on this left-hand side, the square root and the square go away, giving me 2x minus 2. Now what happens on this side? Think for a second. Pause it if you need to. How many of you guys say that this is equal to x squared plus 1? Because negative 1 squared is 1. If you raise your hand if you think that's what it is. Okay. Wrong. What did we do wrong? Okay. When we square a term like this, we can't just square each piece. Okay. What we have to do is we have to remember that squaring means multiply this term by itself. So I am multiplying x minus 1 times x minus 1. How do I multiply these together? FOIL, right? First, outside, inside, last. Okay? So we end up with this. Now I'll let you guys verify that when you do FOIL this out, you get this by combining like terms and stuff like that. That shouldn't be something that you challenge me at this point, hopefully. So now what kind of an equation is this? This is no longer a radical equation, but what kind of an equation is this? That's right, it's a quadratic equation. This is a quadratic equation. And how do we solve quadratic equations? What do? We set it equal to 0. Awesome, you guys are so good at this. So we subtract 2x from both sides, and I'm going to add 2 to both sides. So these cancel out. I get 0 equals x squared minus 4x plus 3. Now, if you're not comfortable factoring, you could absolutely throw this into the quadratic formula. Nothing wrong with that. Perfectly acceptable solution. But this is an easy one to factor. We need two numbers that multiply to be positive 3 and add to be negative 4. Now, if two numbers multiply to be positive but add to be a negative, it means both of them have to be negative. Now, simply think, what things multiply to be 3? Well, there's 1 and 3. That's it. And luckily enough, 1 and 3 do add up to be 4. Or negative 1 and negative 3 add up to be negative 4. So those are our factors. So it means our solution, at this point, our potential solution is 1 and 3. Cool. Now I say potential solutions. You're going to see why in a minute. Okay? Not on this problem, but on the next problem. So, once we do this, remember, we have to check our answers. So let's check our answers. Remember, I'm going to go all the way back to the original problem, not in the quadratic, the original problem. So I get the square root of 2 times 1 minus 2 equals 1 minus 1. So 2 times 1 is 2, so we have 2 minus 2 equals 1 minus 1 is 0. 2 minus 2 is 0, square root of 0 equals 0. And 0 does equal 0, check. So 1 is a solution. So now we do the same thing with 3. So I'm kind of in you guys' way. So we have the square root of 2 times 3 minus 2 equals 3 minus 1. So 6 minus 2, because 2 times 3 is 6. 3 minus 1 is 2. 6 minus 2 is 4. Square root of 4 is 2. So 2 equals 2. Bam. Both of these are our solution. All right, we're getting there. Okay. Now let's look at this problem. The square root of 5x plus 11 minus 1 equals x. So the first thing I have to do here. The first thing I have to do is isolate that radical sign. To do that, I simply have to add 1 to both sides. Look at this. Now I have that radical isolated, so now I just square both sides, like we've been doing. Square and square can go away, so I get 5x plus 11. Now here, we have to FOIL this, right? So we get x plus 1 times x plus 1, and we multiply that out. I'll let you check my math there. We get x squared plus 2x plus 1. Okay? So, again, we have a quadratic. Not too bad. So we just simply go through the same process we did. We get it in relation to 0, so I'm going to subtract 5x, subtract 11, 0, x squared. So 2x minus 5x gives me negative 3x, and 1 minus 11 gives me negative 10. So I'm looking for two numbers that will multiply to be negative 10 and add to be negative 3. Again, if you want to use a quadratic formula, do it. No problem with that. Great. A is 1, B is negative 3, C is negative 10. You're good to go. But factoring is not too hard now. So two numbers that multiply to be negative 10, but add to be negative 3. So they're multiplied to be a negative, so I need one positive, one negative. Okay? Now, if they multiply to be 10, there's 1 and 10, 2 and 5, and that's it. The only two that have a difference of 3 is 2 and 5. So those are our two factors. 2 and 5 are the two numbers we're going to use. But which one's negative and which one's positive? Since they add to be a negative number, I need the bigger of the two to be our negative. So we're going to have minus 5 and plus 2. That means our solutions, our potential solutions, are negative 2 and 5. And 5. So now we need to go back to our original and check these. Okay? So, 5 times negative 2 plus 11 minus 1 plus negative 2. Okay, so multiply the 5 and the negative 2, we get negative 10. Negative 10 plus 11 is 1 minus 1 is negative 2. Square root of 1 is 1. 1 minus 1 equals negative 2. 0. 0 doesn't equal negative 2. It's not correct. So that's not a solution. What that is it's what we call an extraneous solution. It is something that came up as a true solution in our solution process, but it does not actually work in our original problem. Now, what in the world happened? How did we get that? Okay. If we look at our solution process, right, I added 1, that's fine. Ooh, I squared here. If we kind of do the adding 1 piece, right? So instead of doing this subtraction, saying 0 equals -2, if I add this 1 over here, which is our first step, I would get 1. If I add 1 to -2, I get -1. So I get 1 equals -1. That's not true though, right? But if I square both of those, 1 squared is 1, and -1 squared is 1. So when we square both sides, we have the potential of introducing extraneous solutions. So you need to make sure that you always check every single answer you get, every solution. Okay? Now I'll leave it to you to check it, but 5 does work. So that's our only answer. There we go. Okay? Checking your solutions with a radical equation is 100% required every single time. It's not the teacher and me saying, oh yeah, check your answers. No, you have to, because you don't know if you have an extraneous solution or not. Okay? It's possible for both answers to be an extraneous solution, in which case you would say there's no solution. And that's possible. It's possible that both of them work. It's possible that one of them works. It's possible that there are no solutions to begin with. So, make sure you guys check your solutions. Now we're going to do one more problem, because this one's weird in the sense that it's not something we normally do. Okay. The square root of x minus 4 minus the square root of x equals -2. How do I isolate? Do I isolate this one? Do I isolate this one? So there's a couple approaches you can take with a problem like this. One approach is, hey, I've got my square roots on one side, so I can square both sides from here. But then I'm foiling, square root of x plus 4 times or minus x, and that's it. I don't want to foil that. So what I personally like to do is I like to take the simpler of the roots and move it to the other side. So to do that, I'm just going to add the square root of x, giving me square root of x minus 4 equals square root of x minus 2. Okay, if you have -2 plus square root of x, that's the same thing. So from here, I have a single radical over here, so I can square both sides. When I do that, I'm going to write this over here because leave myself some room. This right here just gives me x minus 4. Now over here, I get square root of x minus 2 times square root of x minus 2. I'm going to go through and FOIL this with you so we can see how this unfolds. So what I do first, so I have square root of x times square root of x. So that's the square root of x squared. Then square root of x times negative, so I have -2 square root of x. And inside I get another -2 square root of x. Last plus 4. Okay? So, now I want to combine like terms and simplify things. So I have x minus 4 equals, what is the square root of x squared? Well, just like here where the square root of x minus 4 is squared, when I square a square root, it cancels. So I just have x. Now, these are like terms because our variable expression is the same. They're both square root x. So I can combine these to give me -4 square root x plus 4. So now I have another expression. This is again now a radical expression. So I need to isolate our radical. So to do that, I'm going to subtract x from both sides. And I'm going to subtract 4 from both sides. And what that gives me, the x minus x actually goes away. And then the -4 minus 4 gives me -8 equals -4 square root x. From here, depending on what you're left with, we can actually square both sides of this right now. And the reason we can do that is because if I have the product of two things that's being squared, I can distribute that exponent. I can distribute exponents over multiplication, and similarly with division. I cannot distribute exponents over addition or subtraction. That's why we have to FOIL this. But here, if I squared things, I would just end up with -4 squared times the square root of x squared. Okay. The other thing we could do is I see that -4, -8, they're factors, or they're divisible. I'm going to divide both sides by -4. I'm left the square root of x, -8 divided by -4 is +2. So then we just square both sides, x equals 4. Okay. Now am I done? No. Why am I not done? What do I have to do? Yeah, check it, right? Because it's a radical equation. I have to check the answer every single time. So, square root 4 minus 4 minus square root of 4 equals -2. 4 minus 4 is 0, so I have the square root of 0. Square root of 4 is 2, so I'm going to fill that in. Square root of 0 is 0. 0 minus 2 is -2, and lo and behold, -2 equals -2. That's our solution. We are done. Pretty straightforward and easy. Okay? Now, what if I ask you to solve an inequality? Solve the equality. Pretty easy. And then check. Now, what do I mean by check? The graph of the square root of x looks like this. I'm not going to give you something that like rotates it. That's not happening. So the only thing you're going to get is potential flips, right? So that means you're going to get something that could look like this, or like this. So let's say I want to solve just look at this one here. When it's greater than or equal to 5. Here's 5. You solve the equality to get this value. That means everything to one side of that number is going to work or not, and everything to the other side is either going to not work or work. It's going to do the opposite, right? So if I want greater than, that means everything over here works, nothing over there does. So if you just check on just a number on either side of it, you figure out if that works or not. Easy. Okay? That's it. That's radical functions. They're pretty simple. I'm probably not going to ask you an inequality, so don't panic on that. But like, you didn't do an example. You're good. Okay? I just want you to explain to you how you would do it if I do decide to give you a little tweak. So, that's it for radical functions, you guys. Have at it. Have fun. I'll see you later.